Hello students, hope all of you are doing well. Today I welcome all of you in the next video lecture. Here we are going to discuss about the homogeneous linear partial differential equation of higher order with constant coefficients and how to solve such type of equation and finding the complementary function for such an equation. That is our today's topic. So let us start our discussion. So what are the learning objectives for today's video lecture? To get the knowledge about the higher order linear homogeneous partial differential equation with constant coefficients. Also parallelly we try to understand what is the complementary function of such an equation and how to calculate such complementary function. So let us start our today's discussion. So here we have taken the general form of a homogeneous linear equation of nth order partial differential equation, where we are thinking z is the dependent variable and which depends on two independent variables x and y. So what is the general formula? That is a0 del to the power n z del x to the power n plus a1 del to the power nz del x to the power n minus 1 del y, a2 del to the power nz del x to the power n minus 2 del y2 plus dot dot an del to the power nz del y to the power n equals to function of x and y only. There will be no function of x, y, z, otherwise it will become some other quantities, not linear. So now when we can say this equation is a homogeneous equation, if you look at the equation, then every single derivative, partial derivative that has been appeared in this equation are of nth order. So all the derivatives are of nth order, which gives us the idea that the partial derivatives are homogeneously distributed. So that is why it is known as the homogeneous equation. Now the coefficients that we have written here, that is a0, a1, a2 up to an, these coefficients can either be constant or it can be a function of x and y only. It cannot be function of x, y, z, otherwise it cannot be linear. If particularly we consider all these coefficients are constant, then such an equation is known as the nth order linear homogeneous equation with constant coefficient. So in our syllabus we are having the linear homogeneous equation of higher order with constant coefficients only. Here we will not consider the cases where a0, a1, a2, an depends on x and y. Now how to approach towards this type of question? Whenever such an equation will be given to us, our task will be first of all to convert the equation in terms of differential operator function. So we will introduce the partial differential operators as d stands for del del x, differentiation partially with respect to x one time, first order partial derivative with respect to x. D dash stands for first order partial derivative with respect to y. D and d dash stands for second order partial derivative, one with respect to x, another with respect to y. D2 stands for second order partial derivative with respect to x. D dash square second order partial derivative with respect to y, and so on. So if we substitute all these things in the given equation, the equation will take the form a0 d to the power n, a1 d to the power n minus 1 d dashed, a2 d to the power n minus 2 d dashed square plus dot dot an d dashed to the power n. This whole will operate over z because every term z partial derivative is only we are doing. So this whole will operate over z. Right hand side term is f of xy. So this type of equation first of all we have to bring. Always remember, such type of equation has the solution or the general solution in the fact term, that is z equals to cf plus pi. What is cf and what is pi? Cf is the complementary function and pi is the particular integral. in today's video lecture we want to learn what is the complementary function and how to find out this thing. From next video lecture I will going to discuss about the particular integral. So what is the working rule for finding the complementary function? Let us try to understand it. So we will consider the equation 1 and we will consider the trial solution of such an equation in the manner z equal to f of y plus mx. So this is the trial solution that we have to consider. Now if we differentiate z partially with respect to x, we have m into f dash of y plus mx. F I don't know, f is arbitrary function, so it will become f dashed, and derivative of m, x is equals to m, so this will come outside. So basically capital D of z, del x of z means capital D of z, this is equals to m into f dash of y plus mx. In a similar manner, if we differentiate partially with respect to y, we get f dash of y plus mx only. Second order derivative with respect to x, it will be m square f double dash y plus mx, and so on. Whenever we will have to substitute all these things in the equation, a0 d to the power n, a1 d to the power n minus 1 into d dashed plus dot dot an d dashed to the power n of z equals to 0. This is the most important case while finding the complementary function. Remember, whatever the term are given in the right hand side of the equation 1, you have to consider it as a 0 while you are calculating the complementary function. Later, if there is some non-zero term, that term we will calculate in terms of the particular integral. But if no such term is given, your equation is already given right hand side 0, then no matter, it is automatically 0. But if non-zero terms are given, first of all you have to consider it as 0 and you have to calculate the CF. So now if we just substitute all this value, that is d of z, d dashed of z, d square of z, everything in this equation, we have a0 m to the power n, a1 m to the power n minus 1 dot dot an into 1 f to the power n y plus mx. F to the power n means nth order derivative of f. Why we have written this? Because every term in this equation are of nth order partial derivatives, so it will be f to the power n y plus mx. Since f to the power n y plus mx, this term is a non-zero term because it is a non-zero function obviously. Therefore what will be the 0? Because this product equal to 0, so either of these two term must be 0. Therefore a0 m to the power m, a1 m to the power n minus 1 plus dot dot an, this term or this equation is going to be 0. So this part or this equation is known as the auxiliary equation of the given equation. Okay, so auxiliary equation of the reduced equation or the given equation. So definitely all of you can understand it is an nth order equation. So how many roots will be there? Exactly n number of roots will be there. So what are the roots? Say the roots are m1 m2 dot dot mn. Now for finding complementary function, we have to remember two separate rules. Rule number 1 says that if all the roots are distinct, that is every root is different, m1 not equal to m2 not equal to m3 not equal to mn, every roots are different, then what will be our complementary function? Complementary function is going to be phi 1 y plus m1 x, because already we have considered the solution as z equal to f of y plus mx, where f is unknown function. Here in terms of f I have written phi 1 y plus m1x, phi 2 y plus m2x, phi n y plus mnx. Since n roots are different, so we are having different functions, phi 1, phi 2, phi n. Okay, now if all the roots are equal, that is the second case, m1 equal to m2 dot dot equal to mn, then what we will have, all the functions will be different but sub difference will come as per the rule number 1. So the CF is going to be phi 1 y plus m1x, because all roots are equal, phi 2 y plus m1x, phi 3 y plus m1x, phi n y plus m1x. But since it is repeating n number of times, so for each and every term one x is going to outside with the functions. So here only with the first term there will be no x, thereafter one x will go outside. So x into phi 2 y plus m1x, x square into phi 3 y plus m1x, and x to the power n into phi n y plus m1x. So this rule is applicable whenever you are having the repeated root. So what is the shortcut technique finding the auxiliary equation whenever we are having the equations in our exam? Simply we have to replace d by small m and d dashed by small 1 to get the auxiliary equation. Remember again that complementary function can be found by making the right hand side of the equation exactly equal to 0. If it is non-zero, though you have to consider it as a 0, then only you can find out the complementary function. Second thing is that if the right hand side is already 0, then what will be your general solution? Then general solution will contain only the complementary function. There will be no particular integral at all. If there is no non-zero term present on the right hand side of the function, there is no single function of xy present on the right side. So now let us try to implement this idea to find out the solution of such type of equation. So the first question is, solve del 2z del x2 minus 5 del 2z del x del y plus 6 del 2z del y2 equal to 0. So every single partial derivative here you can see are of second order. So it is a homogeneous partial differential equation. Obviously it is linear and the coefficients are constant. Second order linear equation. So this equation can be written as d square minus 5 into d dashed plus 6 into d dashed square, this whole of z, this is equals to 0. How I can write down this? Because I know that d stands for del del x and d dashed stands for partial derivative del del y, and so on, that I have already declared. So we can write down this. So now how to get the auxiliary equation? So the auxiliary equation we can obtain by replacing d by small m and d dashed by 1, right? Therefore the auxiliary equation becomes m square minus 5m plus 6 equals to 0. So if I solve this equation, we are having two factors, m minus 3 and m minus 2. This is equals to 0. So what are the roots we are having here? One root is m equal to 2, another root is m equal to 3. So both the roots are different. So we can apply rule number 1. Therefore, what is our complementary function? As per the rule number 1, we are having two different functions. First one phi 1, y plus m1x, say 2x, plus phi 2, y plus m2x, so y plus 3x. Okay, so this is the complementary function. So what will be our general solution for such an equation? General solution, z equal to complementary function only. Why? Because in the given equation right hand side is only 0. Let us come to the second problem. Solve d2 plus d dashed plus d dashed square of z equal to 0. So how to solve it? Same technique, that is we have to consider the auxiliary equation first by replacing d by m and d dashed by 1. So we have here auxiliary equation as m square m plus 1, right? M square plus m plus 1 equal to 0. So by Sridhar Acharya formula we can find out the root of such equation, that is minus b plus minus root over b square minus 4ac by 2a. So it is minus 1 plus minus root over 1 minus 4 by 2. So roots are minus 1 plus minus I root 3 by 2. So definitely there are two different root. One is minus 1 by 2 plus I root 3 by 2. Another one is minus 1 by 2 minus I root 3 by 2. So these are the two values of m1 and m2. So what will be our complementary function? By rule number 1, we have the complementary function as CF equal to phi 1 y plus minus 1 by 2 plus root over I root 3 by 2 x plus phi 2 y plus minus 1 by 2 minus I root 3 by 2 x. So the general solution is going to be the complementary function only. Let us come to the third problem. So solve the equation d cube minus 3d square d dashed plus 2d d dashed square z equals to 0. So same thing, d have to replace by m, d dashed by 1. So auxiliary equation m cube minus 3m square plus 2m equals to 0. We have taken m common, rest of the terms are m square minus 3m plus 2 equals to 0. Factors are m equals to 0, m equal to 1 and m equal to 2. Since three roots are different, so what will be our complementary function? Phi 1 y plus 0x, phi 2 y plus 1 into x, phi 3 y plus 2x. Since on the right hand side we are having only 0, so the general solution z is equals to CF only. Let us try to solve the fourth problem. Solve the equation d cube minus 3d square d dashed plus 4d dashed cube equal to into z equal to 0. So auxiliary equation is m cube minus 3m square plus 4 equals to 0. So since it is a cubic equation, so we can have to apply the method of synthetic division or the vanishing factor method. So how to find out the solution of such equation? First of all, I have to substitute some value of m so that the equation will get satisfied. So if I put m equals to minus 1, then definitely minus 1 is going to satisfy this equation, right? Minus 1 whole cube minus 3 into minus 1 whole square plus 4. So here it will come minus 4 and plus 4. So it is going to be 0. So therefore m equal to minus 1 definitely is one of the root of our equation. How to find out the second two roots? By the method of synthetic division that I am going to explain right now. So how to do this method of synthetic division? Let us try to write down all the coefficients of the terms that we are having here. So the first coefficient we are having here, that is 1 d cube. Next is 3d square d dashed, right? The coefficient is minus 3. Third coefficient, it should be d square d into d dashed square. So that coefficient must be there, but here no term, so it will be 0. And last one d dashed cube, so it is 4. Now already we have obtained one factor, and that factor is minus 1. So how to do this method of synthetic division? I have to put 0 here and just add these two numbers. So it is 1. Now we have to multiply this into this and substitute back here. So 1 into minus 1 is going to be minus 1 here. So if we just add this, it is going to be minus 4. Now we have to multiply this into this here and put back here. So it is going to be plus 4. So adding, it will come plus 4. Again I have to multiply minus 1 with plus 4. So it is going to be minus 4. So this term is going to be vanish. So when the last term automatically it will vanish, you can understand your calculation is completely correct. So now these are the coefficient 1, minus 4 and plus 4. These are the coefficient of the reduced quadratic equation. Already we have one root. So what will be the equation now? So m square, this is the coefficient, minus 4m plus 4, this is equals to 0. So that is definitely it is a square equation, that is m minus 2 whole square equals to 0. So what are the values of m? We have m equals to 2, 2, right? So we are having three roots. So what are the three roots we have obtained? The roots are minus 1, 2 and 2. So one root is different, rest of the two roots are same. So what will be our complementary function then? Complementary function is going to be phi 1 y plus m1x, so that is y minus 1 into x, plus for repeated root first term is phi 2 y plus 2x. Now since it is repeating 2 times, so 1x is going to outside, thereafter phi 3 y plus 2x. That is applying the second rule for the complementary function. So what will be our general solution? Z equal to phi 1 y minus x plus phi 2 y plus 2x plus phi x into phi 3 y plus 2x. So this is the complementary function. Since the right hand side is 0, so it is the general solution. So what are the things that today we have learned from this session? That we have learned what is the homogeneous linear partial differential equation with constant coefficient, and how we can calculate the complementary function for such an equation. For your practice purpose, here I have given 3 problems. Please try to find out the solution and let me know in the comment box whether you have get the answers or not. If you feel any difficulty, you can comment. I will try to write down the solution. Thank you all.